Hello and welcome to another episode of Military in Painful Details. At the very beginning of today's material, I have to include a disclaimer. King George class battleships are one of my favorite ships of all time. I have a weakness for quadruple gun turrets, so KGVs arouse in me an unhealthy excitement with their main artillery. So, although I try to be relatively objective in my materials, I can treat or possibly treat these battleships with a little more sympathy than previously analyzed battleships. Although I still think that many of the praises contained in this material are fully deserved, and I also tried to honestly criticize aspects that were not very good, I immediately warn you that my opinion may not be 100% objective. But I will leave this for you to judge. I invite you to watch the next episode of Military in Painful Detail. The next hero of our story is the famous King George V class, with two units participating in the hunt for Bismarck, HMS Prince of Wales and HMS King George V. King George class is probably one of the most underrated battleships designs ever created. As a child, as a little kid, I remember reading the description of the Battle of Kwantan in the first volume of Zbigniew Flisowski's Storm over the Pacific, a famous book in Poland describing World War II in the Pacific theater. I also remember the photos of HMS Prince of Wales and HMS Repulse that I found in this book, as well as the silhouette drawings at the end of the book. Both the battle and the appearance of this ship made such a big impression on me that since then many of my Lego creations have referred to the King George V type. Over time, however, I also fell into the trap of underestimating this ship and jumping over this type to other seemingly more interesting ships, like Iowa class or Yamato class battleships. Much later, when I started to delve deeper into battleships' design history, and when I started to pay more attention to certain details, and I was also older, it began to dawn on me how well designed these warships were. King George V class was very heavily armored, had a heavy broadside compared to caliber of the guns. The ships had great seaworthiness, was very maneuverable for its size, had excellent fire control devices for the main artillery, as well as excellent radar devices. And all this on a relatively modest ships as far as size goes, designed for 35,000 tons. Not bad at all. However, the King George class certainly had its flaws. Some of them were removed, rectified during their service. Some of them characterized these ships until the end of their days and on the end of their service. It is very interesting to compare the path that King George class went through and the final effect with the previous ships, the Nelson class. The Nelsons were a scaled-down hybrid of the G3 and the N3 designs. These large ships were very impressive, the Nelson class not so much, not necessarily so. We know that these battleships had a lot of problems, and although they also had their good sides, for example strong armor, we also know that they were haunted by a whole herd of various problems, and one could say that the entire project lacked proper balance. The push for 16-inch guns that were required to be mounted on them caused the design balance to be disrupted, and the entire project simply crumbled under its own weight. The story of the project that eventually took the form of the King George type is completely different. Its genesis has two parts. The first loosely related to the later battleship, and the second that took part after the Second London Treaty, directly transforming into the new battleship. So let's start by discussing what the designers of Great Britain planned after the Nelson class. In the interwar period, Great Britain continued to lobby for smaller battleships after Washington Treaty. From the chapter of the Nelson class, we know that after the Washington Treaty, Britain and other powers as well sought further reductions at the London conferences in 1930 and 1936. Unfortunately, in the first half of the 1930s, it became clear that the armament limits would not be maintained in their current form. However, this did not stop Britain from trying to reduce them further. They seemingly pushed for battleships of no more than 22,000 tons and 11-inch guns. It was clear that most powers, especially the US, would find such a limit unacceptable. In truth, the British wanted to have something they could leverage by intentionally proposing such a small battleship, while in reality they aimed to set the limit at 25,000 tons and 12-inch guns. Nevertheless, this was still a very low tonnage, very small tonnage for a modern battleship, in effect the level of the larger dreadnoughts of World War I. Unfortunately, in the meantime, the international situation began to deteriorate significantly. Japan increasingly pressured China, Germany demanded to overthrow the provisions of the Treaty of Versailles, and France, facing the prospect of a renewed armament race, sought favorable limits for herself in order to be able to repel not only Italy's Regia Marina, but also the new German fleet. Great Britain was preparing for the upcoming conference while at the same time conducting design work on future battleships, 25,000 tons, 12-inch guns, and a speed of around 23 knots. Initially, the new battleship was a scaled-down version of a Nelson-class battleship. It was to have a smaller caliber of guns, be devoid of an armored command bridge, and have fewer fire control stations. As with Bismarck early designs, the use of completely outdated casemates for secondary artillery was also considered. But there were also some sensible ideas, such as increasing the number of anti-aircraft guns from 3 per side to 6 per side, although a reduction of caliber from 4.7 inches to 4 inches was considered. In addition, steel torpedo launchers were considered, this time however a 5-tube launcher placed on the main deck, 1 per side, for a total of 10 torpedo launchers. There was also interest in strong aviation facilities supporting 6 Swordfish aircraft with proper armament for these bombers. Another issue was armor. Regardless of the caliber of the future battleship main artillery that could be established at the conference, the new battleships would have to fight for a specified period of time against ships more heavily armed than themselves, such as Nagato class in Japan, Maryland class in United States, and even Kongo, Ise, or Nevada classes. All of them had bigger caliber guns ranging from 14 inches to 16 inches. They, therefore, had to have adequate protection. In addition, an increased threat from the aircraft was noticed, including dive bombers. Dive bombers were the hottest trend that season, flavor of the month you could say, although their effectiveness was greatly exaggerated at the time. The tests conducted were indeed successful, but they were conducted against a stationary target, not defended by anti-aircraft artillery fire. The actual accuracy would have been much lower. Despite this, it was considered such a big threat that defense against bombs dropped by dive bombers became very important. Fortunately, this went hand in hand with the tendency to increase the thickness of the deck armor, trying to improve protection from long-range shots hitting the battleship at steep angles. At this stage of the design, the Royal Navy was considering 2 key aspects of a ship defense: underwater defense and the shape of the armor belt. The designers were debating at the best way to approach the problem of passive protection. In the case of these early 12-inch guns designs, these 2 aspects were somewhat combined into one issue. The Nelson class had a sloped side armor belt placed inside the hull. In theory, apart from the actual increased defense against projectiles, this type of armor scheme was supposed to have an additional advantage in the event of a torpedo hit. Because of the space between the armor belt and the ship's side, the anti-torpedo bulkhead and the hull, the shockwave from a torpedo hit would theoretically spread out into the space between the belt and the side of the ship. This would make the whole system more effective, at least in theory. Unfortunately, it was not necessarily so. The system itself worked, meaning that the shockwave was indeed deflected, but the potential gain from allocating this space for the shockwave to spread out was not as great as had been assumed. Consideration also began to be given to the tactics in which the ships would be used and to the potential adversary. We know that the only significant adversaries for Britain at that time were Japan and the USA. Both powers were keenly interested in fighting at longer distances. Great Britain, partly influenced by war experience in World War I, preferred fighting at medium distances of about 14,000 meters. However, to reach such a distance, the battleship had to close with their opponents while being under fire from the enemy ships. The solution was a thick armored deck and thick side armor, but not so dramatically sloped as in aerial designs and placed outside the hull, not inside. Anti-torpedo defense was to be a layered system, the one invented during World War I, which Britain first abandoned and now decided that it in fact was a very good idea. The layered system involved using 3 or more successive sectors before reaching the actual anti-torpedo bulkhead. The sectors were a combination of void and full rooms. Various schemes were tried, but in the end, the most effective scheme was found to be the void, full, void sequence of layers. When impact occurred, the first void room was to provide a place for the shockwave to spread. The second full room, usually containing liquids such as water or fuel, was to catch the fragments and shrapnel and slow down the shockwave, and the final void layer served as a safety buffer, providing room for the final dispersion of the shockwave and also to prevent the effect of increasing pressure on the bulkhead as a whole. Behind these 3 layers was the anti-torpedo bulkhead. This type of armor scheme, a thick armored deck, slightly angled thick armor belt but placed outside the hull, and a layered anti-torpedo defense system was eventually used on King George class battleships. The first design of the new battleships equipped with 12-inch guns, presented in August 1933, brought with it a cold shower for the designers. The initial calculation of the displacement to achieve the intended result was 35,150 tons. Even after a rather strict trimming down, it was possible to cut down this design to just over 30,000 tons, far above the planned 25,000 tons earlier on. This rather sad conclusion showed that designing a satisfactory battleship with such a low displacement would be a great challenge. The designers were in a bit of a pickle. They could not satisfy the requirements of the board on the proposed displacement, but instead of pushing for increased displacement limit, they deluded themselves by believing in false informations and some wishful thinking. It was assumed by the designers that France, Germany and Italy would not want to build larger battleships. The Dunkirk class was estimated at 26,000 tons, the German Scharnhorst at 20,000 tons, probably before the design had increased displacement later on, and the Italians were not suspected of wanting to raise the bar, which is exactly what they did with the Littorio class. Based on false information, it was also assumed that the most important power, the USA, would actually agree to a limit of 28,000 tons, a compromise to the 25,000 tons proposed by the United Kingdom. As for Japan, it was also assumed, again wrongly, that it would agree to a limit of 25,000 tons and 12-inch guns, not wanting to be seen as a country sparking a new arms race. Thus, the design 12N assumed 28,000 tons and 8 12-inch guns for the main armaments in 4 twin turrets. 12N was not particularly impressive, and the next design 12O with 3 triple turrets was quickly developed. At the time, the low speed of 23 knots began to be questioned. Considering the existing treaty limitations, the battleship built at that time would have to serve until the late 1950s, early 1960s. Moderate speed of 23 knots did not look very encouraging in such a long perspective. Therefore, designers began to look at faster battleships with speeds reaching 27 knots. The most interesting changes, however, concerned the armament. First, the issue of secondary artillery was raised. It was stated that separate 6-inch artillery was a luxury for such a limited tonnage and that the ship should have uniform secondary artillery of a smaller caliber. Then the controller raised the issue of the main artillery, wanting to place it in 5 twin-gun turrets arranged as in the Miyoko heavy cruisers. That is, 3 in the bow. In the Nelson-class arrangement, the middle turret was placed in the superposition and 2 turrets in the stern. Unlike its predecessors, this one had no torpedo launchers. It would be one of the most interesting but visually difficult battleships. This project was designed as 12P. A 12.5 inches thick main armor belt was chosen for the magazines, 11.5 inches thick for the engine room, and the armor deck was to be 5.5 inches thick. In the case of the 12P project, the armor belt thickness was reduced by half an inch. For one project, the Oklahoma class scheme was considered for the position of the main artillery, that is 2 triple turrets and 2 twin turrets, but it was decided that if triple turrets were to be designed, the ship should be armed only with them, not with a mixture of triple and twin turrets. This resulted in the 12Q project with 4 triple turrets. Even at a low speed of 23 knots, the ships required a minimum of 45,000 shp, which pushed the displacement on 12P and 12Q beyond provided limits. Therefore, none of the project fit into the designated tonnage. Even the smallest 12N weighted 28,130 tons. Of course, these are estimates. The weight could have been much greater. And 12N was still considered as inadequate. Subsequent designs 12R and 12R and 12S sought savings in unified secondary artillery, but at the same time used 3 triple turrets for the main artillery. 12T, on the other hand, had 4 twin turrets, all weighted around 28,500 tons, again exceeding the limit provided by the controller, the DNC. It seemed that the designers had reached the ceiling of what could be achieved with this displacement. On September 27, 1934, Stanley V. Goodall, responsible for the new designs, called a staff meeting to discuss the new projects with naval officers. The ships made a positive impression, with criticism mainly directed at the secondary armament, which is a bit curious. The gathered officers wanted to separate the secondary artillery into surface artillery and heavy anti-aircraft guns. However, Goodall pointed out that such a separation would cost a lot of weight. An interesting comment is quoted here by Norman Friedman, who quotes the opinion of 2 destroyer captains. They stated that they would rather attack a ship with 6-inch guns, with 6-inch guns, than one with 12 4.7-inch guns, indicating that in their eyes, as a captain of the destroyer, the number of guns was more dangerous than their caliber, which may not necessarily reflect the actual state of affairs. Meanwhile, it turned out that the information about the intentions of the foreign fleets was incorrect and inaccurate, and in fact designers were working on a completely wrong premises. United States never intended to agree to a limit of 28,000 tons, and they also did not intend to agree to a 12-inch guns. The Americans were working on battleships with a displacement of 35,000 tons, armed with 14-inch guns, but they could go down to around 35,500 tons, but the caliber of the main armament would remain unchanged. Things began to get complicated. The British naval superiority over its opponents was slowly eroding. France was arming itself against Italy and Germany, Italy against France, Germany was slowly entering the path of naval armament, and in the Far East, Japan was still a major threat. The plan, in which Great Britain would send forces sufficient to defeat Japan in the Far East, while maintaining forces sufficient in the European theater to control the next power in line, ceased to be reasonable or practical. Japan, the main planned opponent of the Royal Navy at the time, had no intention of slowing down the expansion of its naval forces, even if it burdened its budget beyond measure, and continued to apply pressure during the talks about naval treaties. In such chaos, the disarmament conference in London took place, which began in December 1935 and resulted in the Second London Naval Treaty in 1936. The final result of those debates was a battleship with a displacement of 35,000 tons and 14 inches guns. However, these limits only applied to Great Britain and the USA. Japan withdrew from the conference and the disarmament treaties. Germany had its own agreement with Great Britain, and both France and Italy accepted some provisions like displacement and ignored others like caliber of the guns. Now, this concludes the first stage of King George V class design path. This stage established mainly the armor scheme and the universal secondary artillery, as well as set the stage for increased speed of a future battleship. For Great Britain, the position of the other powers regarding further disarmament was a big surprise and a huge problem. The anticipated very optimistic scenarios turned out to be completely false. The USA did not want to agree to Great Britain's proposal, Japan left the talks, Germany, France and Italy began to play their own game with consistently increasing tonnage of subsequent generation of battleships. It became clear that battleship with 12-inch guns with displacement of less than 30,000 tons no longer made the slightest sense. The turn of September and October 1934, even before the Second London Naval Treaty, therefore brought a change in the planned battleships. The first of the new design is a much larger ship than previous designs, equipped with 4 triple turrets with 14-inch guns, universal secondary artillery of 4.5 or 4.7 inches caliber, and a speed of 28 knots, displacing about 35,000 tons. The British still had the illusion that they would manage to save at least some of the provisions of the disarmament treaties, and the director of naval construction asked the designer to reduce the ship's displacement to around 30,000 tons. This resulted in another design, a very distant ancestor to the King George V class. Herbert S. Pengelly, the person responsible for new battleship designs at the time, created 3-turreted ship protected by side armor of 12 inches and 11 inches thick. The first value is for the magazines, the second for the engine room, with a 5-inch armored deck. The alternative was a 4-turreted ship but with weaker armor, a 9 inches 8 inches thick sidebolt and armor decks of 3.75 inch and 2.5 inch. These designs were designated as 14A for the 3 turrets and 14B for the 4-turret design. In October 1934, in view of the prospects of the new disarmament conference, the staff set new requirements and requested 2 new designs, A and B, this time without numbers. Design A was to be a reasonable design for the permitted tonnage, while Design B was to be the smallest design possible with the new guidelines. Design A assumed 4 triple 14-inch turrets, Design B 3 such turrets. Secondary artillery would be 12 twin mounts for A and 10 twin mounts for B. Speed was at 23 knots for both ships. However, the armor was increased to protect the ship from fire from 14 inches guns at increased range. The designer noted for the first time that one way to meet these requirements is to obtain adequate firepower and armor on a limited displacement would be to use a quadruple gun turrets. At the end of the October, DNC prepared 2 new projects in accordance with staff guidelines, 14 TLA and 14 TLB. 14 TLA made a good impression as a sensible and a balanced project, although there was still consideration of reducing this project to the limit of 35,000 tons of displacement, which was assumed to be acceptable for the USA. As we know, it was not. However, the cost of such lightening would be quite high. Thinner armor near the engine room, both side and deck, and speed reduced to 21 knots, and this was no longer acceptable. DNC came to the rescue and presented the 14Q project, the first with quadruple main artillery turrets. 3 turrets provide adequate firepower, and displacement, thanks to the use of 3 instead of 4 turrets, was reduced to 32,800 tons. The rest of the characteristics were at the level of the 14 TLA project, which also means a quite low speed. The 14Q design made a positive impression and was initially selected as one to be built if the disarmament conference did not bring about further cuts in ship tonnage. A problem that would plague the King George V class during the early days was their unreliable armament. King George V class battleships would be armed with completely new guns which did not exist at the time. The Royal Navy had no modern 14-inch guns while the designers were working on different projects. In December 1934, the director of naval ordnance drew attention to this. The new battleship would be armed entirely with new guns and new turrets, both in terms of main guns and the secondary artillery. Their weight was calculated on the basis of earlier or similar guns, but the process of ordering these weapons would have to be sped up, a situation similar in some cases to the Queen Elizabeth class, where armament was also a very risky gamble for Winston Churchill. In the case of the Elizabeths, the armament was a complete success, but in the case of King George class battleships, unfortunately only partial. Meanwhile, the beginning of 1935 brought a definitive confirmation of the tonnage of the future ships, 35,000 tons. Project 14Q was a proof of concept. At the design tonnage 32,000 tons, it was possible to design a satisfactory battleship, well protected and armed with 12 14-inch caliber guns. The increased tonnage limit to 35,000 tons could therefore be devoted to improving one characteristic that was not at appropriate level in this project, which of course means speed. Pengelly created the 14C project. The ship was equipped with 12 14-inch guns in 3 quadruple turrets. The secondary artillery consisted of 10 twin 4.5-inch gun mounts. In addition, 4 pom-pom mounts and few of the machine guns were also considered for anti-aircraft fire. Above all, however, the ships had a new hull shape resembling the actually built King George class battleship hull, and a much more powerful engine room, giving the projected battleships 100,000 and 112,000 SHP, which would allow these ships to accelerate to 29 knots. Due to the fact that the caliber of the guns had not yet been finally determined by the London Conference, the diagrams or the drawings were also prepared for 15-inch or even 16-inch guns. The 14D and 14E projects were also created. The 14D project sacrificed firepower for increased protection. The side belt was 14 inches thick at the magazines, 13 inches thick at the engine room, and 6.25 inch and 5 inches thick respectively for the armor deck. Of course, first value is above the magazines and the second value is above the engine room. However, Project 14D had only 8 14 inches gun. The 14E was an intermediate design between the 14C and the 14D. It had a constant 12.5 inch belt and a constant 5.25 inch armored deck. 14E had the armament of the future King George V class battleships, that is 2 quadruple turrets and 1 twin turret for a total of 10 guns. During this period, we also learn a bit of the tactics that were envisaged for those battleships. DTD, a director of tactical division, assumed combat at distances of 12,000 to 16,000 yards, 11 kilometers to around 14 and a half kilometer. He also assumed that if it were possible to use aircraft, the combat range could be significantly increased even to 26,000, 29,000 yards, less than 24, 26 kilometers respectively. He noted that regardless of the above factors, the battle would certainly start at a greater distance than the preferred one, which was the case in reality. Thus, a large number of guns were preferred for combat at a longer distance, due to the case of observing the fall of shells. The more shells fired in a salvo, the easier the observation. Again, due to the lack of a final decision regarding the caliber of the guns of the future battleships, a project was also prepared armed with 3 triple turrets with 16 inches guns. All designs had a unified 4.5-inch caliber secondary artillery as one on the rebuilt Queen Elizabeth class battleships or Renown class battlecruiser. Norman Friedman also provides another interesting tidbit showing the technological leap between World War I and World War II. The new designs were powered by machines capable of producing 112,000 shp, but requiring only 2,875 tons. In the Nelsons, machines producing 45,000 shp weighted 2,450 tons, and in the case of HMS Hood, 144,000 shp was achieved at almost 6,000 tons. You can see how a modern boiler and engine room not only reduces the weight of the entire installation, but also dramatically improves performance. Next in line was the 14F project. It returned to the artillery armament arrangement of the 14C, that is 3 quadruple turrets, but reduced the speed and therefore the size of the engine room to 26 knots while using a smaller hull. The reduction of speed allowed for increasing the armor to 13 inches and 12 inches side armor and 6 inches and 4 inches of the deck armor. Unfortunately, just as the 14-inch guns designs were close to being locked in, Germany declared that their new battleship would be armed with 15-inch guns. This meant that the designs had to be revised. 15-inch guns were thrown into the pool of possible armament. A quadruple turret with 15-inch guns was not considered, only a twin or a triple turret. A number of designs were prepared due to the fact that most of the design work had already been done for ships with 14-inch guns. DNC could produce the appropriate designs very quickly. The 15A and 15B designs were created, as well as the 16A and 16B. Projects 15A and 15B were armed with 9 15-inch guns in 3 turrets. Project A was faster, up to 30 knots. Project B was better armored, but could only reach 27 knots. Project 16B, the earlier 16A, was rejected almost instantly, also reached 27 knots and had 8 16-inch guns, 2 triple turrets, curiously, and 1 twin turret. On September 20, it was decided to build battleships armed with 9 15-inch guns, and the project was to be developed as 15C. But in the meantime, we have another plot twist in our history. When it was already decided to choose the 15-inch guns, 15-inch artillery, the United States unexpectedly agreed to limit the caliber to 14 inches. The first Sea Lord quickly found that, the 15-inch guns designs were, not really well balanced anyway. It's not like we wanted to build them, right? So a new package of designs with 14-inch guns was requested again. 4 different designs were created: 14G, 14H, 14J, and 14K. Designs G, J, and K had 3 quadruple turrets, while 14H had 3 triple turrets. Designs G and H were armored like the earlier 14D, while designs J and K were slightly lighter. The ships accelerated to 27, 30, 28 and 29 knots respectively. The safest choice was 14J, and based on it another version was created, 14L. The idea was to reach a compromise between the appropriate speed, which is 28 knots, the appropriate armament, which is 12 14-inch guns, and appropriate armor, preferably as in the 14D design. One of the biggest issues at that time was the shape of the hull. The hull had to be able to fit both very large barbettes of quadruple turrets, leave enough room for suitably wide anti-torpedo defense, while at the same time ensuring that the hull had a favorable shape from the point of the hydrodynamics. But we will come back to this issue in a moment. 14L decreased the power of the machines compared to the previous 4 projects to 100,000 shp on a 2,550 tons. It also reduced the size of the magazines for a better shape of the hull, which in turn shortened the length of the citadel, and this again allowed for an increase in thickness of the deck armor to 6 inches and 5 inches respectively for magazines and engine room. Unfortunately, the ships, this design still had a rather soft front. The bulkhead protecting the front of the forward magazine was just too thin. The aft magazines were somewhat better protected. They were in the shade of the umbrella of the armored deck, protecting the steering gear. It should also be remembered that unlike Bismarck, the British had wisely placed the powder magazines under the shell magazines. The solution chosen to eliminate the soft front was to extend the 6-inch armored deck about 12 feet, which is 3.6 meters, in front of the magazine of the turret A and behind the magazine of the turret Y. The controller, however, was still not fully satisfied and wanted further changes. He wanted to shorten the length of the propeller shafts by moving the engine room further back to the stern of the ship. However, this would have grouped the secondary artillery in the forward part of the ship because the space needed below armored deck for the engine room. He also wanted to use one funnel, not two, to make it more difficult to determine the ship course and speed, a relic, in fact, from World War I. The changed design was designated 14N. In January 1936, 2 important changes were introduced. The first concerned the new secondary artillery. These were new 5.25 inches gun, 133 mm guns. The new battleship was to carry 8 twin mounts, 4 per side. The second change concerned the anti-torpedo defense system. It was decided that in the designed layer or sandwich system, the middle layer should be filled with fuel, which would be gradually replaced by water with use. This had many beneficial effects, the most obvious being a significant increase in the operational range of the ships. The King George V class battleships could sail almost twice as far as the Bismarck, at least according to the designed requirements. We will get back to this aspect in a moment. Another benefit was much better stability, as well as the ability to control the roll of the ship depending on the damage sustained. The changed design, but still with the engines and funnels set as in the 14N, was named the 14O. The main drawback of the new ships, however, was their armor. It was considered that in light of the information about 15-inch guns mounted on the battleships of other powers, the existing armor might be insufficient. It was considered that although the current level of metallurgy gives much better results, in fact the new 13-inch armor effectively protects on the same level as the older 14-inch armor, the commander of a battleship should not give up or should not have to worry that while he was approaching the preferred battle distance, his ship will be sunk on the way. Thus, one quadruple turret was replaced with twin turrets, and the weight savings obtained thanks to this were allocated to strengthening the armor. The thickness of the armor belt was increased to 14 inches at the magazines and 13 inches at the engine room. The design was designated as 14P and was in fact used, a very close to the built King George V type. Here we come back to the issue of the width of the hull or the shape of the hull that had to fit large barbettes of the quadruple turrets. There was still the issue of the arrangement of the turrets. Which turret should be the twin one? From a defensive point of view, it would be best to have turret A to be twin. The hull was still relatively narrow here, and the wide barbette of the quadruple turret was a big problem as it would squeeze the torpedo protection. On the other hand, the twin turret weighed much less and did not require such a big investment in weight to be put in superposition. Ultimately, weight economy was chosen and the twin turret was placed in superposition B. At that time, decisions were made about the shape of the superstructures, divided in two parts with a catapult in the middle, and the two funnels, and the arrangement of the secondary and anti-aircraft artillery. These modified designs were designed 14P with, I don't know how, what it's meant in English, but with, a little mark above the letter P, and it became the King George V class. Finally, when information about problems with accepting the caliber limit of the main artillery among other navies was confirmed, an additional 1 inch of side armor was added to the King George V type. Thus, the ship had 15-inch armor belt at the magazines, 14-inch at the engine room, and respectively a 6-inch and 5-inch armored deck. Even during construction, minor changes were introduced to the ships, mainly in the area of anti-aircraft artillery. Curiously, it was decided to equip the ship with an ASDIC also. Ultimately, the first ship to be commissioned, HMS King George V, displaced 36,230 tons standard. For comparison, the other ships at the time of commissioning, Bismarck was 41,700 tons, HMS Hood 41,200 tons, and HMS Rodney 34,270 tons. Initially, only two ships were planned to be built to this design, HMS King George V and HMS Prince of Wales. However, it was decided to avoid a lengthy design process, and the matter was quite urgent. A new battleship was needed yesterday, to build another three ships to this design, HMS Duke of York, HMS Anson, and HMS Howe, to the same design. These 5 ships constituted the King George V class. Now, from all of the above, it can be seen that the new British battleship went through quite a long design process before construction was even started. Perhaps that is why it was such a good battleship. It was preceded by many years of discussion and design work. This also shows what effect can be achieved on a fresh, newly created project, but supported by design and tactical experience. The Nelson class was a battleship scaled down from a much larger, much heavier, much more impressive N3 and G3 designs, and this had an unfavorable effect on its characteristics, even though its displacement was almost equal to the new battleship. The King George type was created almost from scratch, with a well-defined role to fulfill, well-defined probable opponents it would face, and well-defined threats it would have to conquer, including ships more heavily armed than it. It was far from ideal, no discussion about that, but for its tonnage, it was a very, very well-designed battleship. So, what are the final characteristics of ships of this type? In terms of thickness and protection of the armor, King George V class presents a very, very high standard. Practically, only the Yamato class surpasses this ship in terms of the sheer thickness of its armor belt and deck. The King George V armor belt is 414 feet long and 23 feet 6 inches high, so it is over 126 meters long and over 7 meters high. It stretched from turret A to the turret Y. The armor belt was 15 inches thick at the magazines and 14 inches thick at the engine room. Below the waterline, it gradually thinned out to 5.5 inches at the magazine and 4.5 inches at the engine room. The armor belt supported the armored deck, consisting of a single plate 6 inches thick at the magazines and 5 inches thick at the engine room. In addition, it also protected the magazines extending forward of the turret A and backward from the turret Y, providing an umbrella effect outside of the armored citadel. Its main role outside the citadel was to set off fuses and protect the magazines from shrapnel. Additionally, it reinforced the hull structure. The upper deck was made of 1 inch and 1¼ inch of a ducal steel, and the armored deck itself was also backed on ½ an inch of the same steel. The magazines additionally had another protective deck, 1.1½ inches thick, to protect against shrapnel. The armor deck, due to the fact that it was placed very high, protected a significant part of the interior of the hull and provided the best protection against bomb attacks. The barbettes were protected by 13 inches to 11 inches of armor for turrets A and B, and 13 inches to 12 inches for the barbette of turret Y. The turrets themselves were quite lightly protected, having 13 inches of armor on the front, 9 inches on the sides, and 7 inches at the rear, finally 6 inches at the top. The secondary artillery was protected only from shrapnel. The armor layout of the turrets was quite controversial. The thickness itself may not necessarily be the case, but the way it was laid out. The turrets had almost vertical front walls. The idea was that this would provide better defense against fire from a greater distance. At shorter distances, on the other hand, the turrets, thanks to their low profile, would be difficult to hit. In reality, however, a conventional shape should have been used, with the turret's front angled in an appropriate manner. Both the command bridge and the DCT, Director Control Tower, were also lightly armored, protected practically only from shrapnel. What did this whole system mean? In practice, the King George V type extended its zone of invulnerability to 16 and 15 inches shells, impact at 19-degree angle, from 16,000 yards to 30,000 yards. For lower calibers, these data look even more interesting, including practically a direct hit from German 11-inch from 8,500 yards at an angle of 19 degrees to about 7,500 yards for a real shot. Of course, those zones of invulnerability are not accidental. If we can recall, the Royal Navy wanted to fight at a distance of 12,000 to 16,000 yards. Theoretically, they managed to create a ship capable of starting the fight at a much longer distance and approaching to the preferred range of conducting the battle, all in relative safety. Now, does the immunity zone mean complete invulnerability to fire? Of course no. Of course not. First of all, it should be noted that the immunity zone is, a theoretical zone. Secondly, hits with such heavy shells always have some effect, always. The crew of the turret can be shaken and injured, equipment can jam, plates can loosen, leaks can develop, etc. Cumulative hits on superstructures and sectors above the armored citadel can also cause lost control of the ship. In case in point would be the USS South Dakota or Hiei, and even finally Bismarck itself, show that it is not at all necessary to penetrate the armored citadel to lose control of the battle. The idea of immunity zone is to protect sectors that are key to survival from specific caliber of shell at specific distances. The thickness of the armor and its extent must still provide protection against incapacitation of the battleship. Unprotected or less protected elements of the ship should be placed so that a hit poses less threat to them. It is not as dramatic in its consequences. In this respect, the King George class was designed very, very efficiently. The armored citadel was superbly protected. The magazines were placed far from potential danger. The command post was left unarmored, rightly arguing that a hit in this area was very unlikely. the expenditure of weight was very high, and the practice of commanding the ship also indicated that very rarely during the battle the ship was commanded from this armored post. Consequently, light armor was chosen, protecting against the more likely impact of shrapnel. The light construction, however, did not activate the fuses of the heavy armor-piercing shells. And finally, the anti-torpedo defense, the layered system. The main anti-torpedo bulkhead worked well. The problem was the water tightness of the sectors behind the anti-torpedo bulkhead. It was difficult for any ship to withstand a hit and the consequences of the hit, as HMS Prince of Wales received during the Battle of Kuantan. But perhaps if the ship had been better designed and also better made in terms of water tightness of the engine room, boiler rooms, generator rooms, it might have been possible to keep the ship afloat longer or even tow it to port. As it was, however, water penetrated through the ventilation system, through the faulty and hastily fitted watertight doors, faulty seals of the cabling, slow reaction of the rescue crew, and ultimately sealed the Prince of Wales' fate. However, in the event of hits in the main anti-torpedo sector, this sector worked as intended, protecting the ship from the effects of the torpedo explosions. Taking the above into account, we now know why it was so important for Great Britain and its ships to set a limit on the caliber of their main artillery guns. The King George V class battleships were proof against fire from their designated opponents, but the line was, very, very thin. The carefully thought out puzzle that the entire system, the entire armor or protective system was made of is also impressive. The preferred combat ranges, the tactical thought of how to approach this combat, both in terms of offense, in example, how to stop the fleeing enemy, and defense, how to withstand fire from larger caliber guns while shortening the distance to the chosen combat range, it is all a very impressive achievement. Just as the armor was practically designed without a hitch or without a flaw, so the armament was causing a lot of problems. Both the main artillery and the secondary artillery were completely new guns and they were mounted in a completely new mounts, including for the first time in the Royal Navy a modern quadruple turret. This caused many problems, some of which were resolved in time, but some of which weren't. However, in the initial period when the ships were very dynamically introduced into the service, the new turrets were very unreliable and constituted a serious flaw, a serious disadvantage of this battleship. Unfortunately, in a rather dramatic circumstances, it turned out that the 5.25-inch secondary artillery were very good as anti-surface guns, but not so good as anti-aircraft guns. HMS Prince of Wales learned this the hard way. The situation was drastically changed by introduction of the proximity fuses in 1944, the result of cooperation between the United States and the Great Britain. This cooperation brought many interesting innovations for both powers. It was the work of the so-called Tizard Commission after Henry Tizard. The proximity fuse was a complete change of quality for these guns, turning the ineffective boogeyman into a deadly weapon. In the meantime, however, the fire control system for these guns was also refined, overcoming the initial difficulties with the high-angle control system. Overall, in the first period of the World War II, the 5.25-inch guns were good as anti-surface weapons, but not good as anti-aircraft guns. Later in the war, they were also pretty good as a deterrent for air attacks. However, the 5.25-inch guns were very good guns in their own right. They had their not so favorable features, such as the heavy turret in which they were mounted. The turret's rotation speed left much to be desired, and in the event of a loss of electrical power, manual operation of the turret was exceedingly difficult, again, as the HMS Prince of Wales had a chance to find out. In terms of firepower, however, they were at a very high level. These guns were the main armament of the Dido-class cruisers, and in this role they proved themselves excellently. Towards the end of the war, After the introduction of proximity fuses, they were among the best universal artillery guns in the world. In the early stages of World War II, anti-aircraft defense was Achilles' heel of the new battleships. 40mm pom-poms were capricious, had a relatively short range of fire, but also they lacked deterrent tracer shells. Japanese pilots that were attacking HMS Prince of Wales may not have been aware that they were being fired at all. In addition, the shells had a low muzzle velocity and a short effective range of fire. This meant that although in the interwar period they were a dangerous weapon, as aircraft performance improved rapidly in this time, the offensive capabilities of pom-poms decreased significantly. Machine guns were almost completely useless, as was one of the results of the Operation Catherine, the UP launcher, unrotated projectile rocket launcher. A rocket launcher that, throws a mine suspended on a wire attached to a parachute. Well, in theory, an aircraft could catch on such a wire and pull the mine toward itself. Well, I will leave it to the viewer to judge how dangerous this weapon was. Later, the ships were fitted with 40mm Bofors and 20mm Ehrlichons of American production, not as abundantly as on the US Navy ships, but a certain density on decks could be observed. This significantly reduced the threat of air attacks later in the war. And finally, the main armament: 10 14 inches guns, 2 quadruple turrets A and Y, and 1 twin turret bay placed in superposition on the bow. The guns themselves were new to the Royal Navy. This caliber had not been used in the British fleet until then. Only HMS Canada, built originally for the Chilean Navy, also had this caliber, although completely different guns. Fortunately, the Royal Navy decided to return to earlier proven solutions, and the new guns had completely different characteristics than the 16 inches guns mounted on the Nelson class. The BL 14/45 Mark VII were new guns designed in 1937. They did not have a wire wrap along the barrel, which made them lighter, more accurate, resistant to the whiplash effect, and they did not wear out as quickly as the Nelson and Rodney guns. Also, unlike its predecessors, the gun could fire 2 shells per minute, a rapid increase compared to the Nelson guns. At least in theory and when everything worked as it should. The design shell was a heavy shell, 720 kilograms, 22 kilograms of explosive, and with a low muzzle velocity of 757 meters per second. The guns had a surprisingly large kick or large punch for this caliber, and thanks to the large amount of explosive and high quality of workmanship, unlike the shells from the World War I, any hits could prove to be fatal. The turrets in which the guns were mounted were a different story altogether. Unfortunately, they were as capricious as they were pretty, which is to say, very much so. The quadruple turrets Mark III weighted 1,582 tons, the twin turrets Mark II weighted 915 tons. Both were complicated devices and had almost identical features. The maximum elevations of the guns was 8 degrees per second, the maximum rotation of the turret 2 degrees per second. The entire firing cycle was completed in 30 seconds. The turrets were constructed with particular consideration of the appropriate lessons learned from World War I. Much attention was paid to securing the turrets against fire and flash magazine penetration. Particular care was taken to protect the propellant charges from ignition. Among other things, a special fireproof cage was designed, resistant to fire, resistant to flash, in which the charges were placed before being transported to the chamber under the turret. So what was the problem? The turrets were complicated devices and their operation required an experienced crew. They were also completely new devices and many of their features were new to the Royal Navy. This increased the need for a trained crew. There was no source of previous knowledge, there was no senior gunner who served on Battleship X with similar guns. Fresh and thorough training was needed. and this required time which the Royal Navy did not have. The complicated turrets were therefore unforgiving of mistakes, and they had to be operated by crews who had neither the time nor the experience to learn all their nooks and crannies. It seems that this time the Royal Navy went a little too far in the other direction. The effort put into ensuring the safety of the turret, the anti-flash doors, the fire prevention system, although of course with good motives, they caused their unreliability. And as it turns out, the firepower of the King George V type, although theoretically quite impressive, in practice, due to the capricious turrets, was rather disappointing, as we will see shortly. The fire control system looked quite different. The King George V type had one of the best such systems in the world, AFCT Mark IX, Admiralty Fire Control Table Mark IX. In addition, the DCT Director Control Tower was equipped with the Type 284 radar. It was not yet as high quality set as those from the end of the war, but it already at the start of the war offered certain possibilities. During the fight with Bismarck, for example, the Type 284 was able to determine the range of a target from a distance of almost 23,000 meters and observes the fall of shot from 12,500 meters. For full 25 minutes it was operational and working as intended. However, although it did not play a major role in our engagement against the Bismarck, its test was so positive that it was worked on urgently, and in 1943, in the battle with Scharnhorst, HMS Duke of York showed what the improved Type 284M gunnery radar could do in combination with classic aiming and classic range-finding. The Director Control Tower and the turrets had large rangefinders. In the turrets they were 42 feet long, less than 13 meters, and on the DCT Director Control Tower they were 15 feet long, 4.5 meters. All the information collected by this equipment, by the DCT, the radars, the rangefinders on the turrets, went to the Admiralty Fire Control Table Mark IX. AFCT Mark IX also had enemy movement mapping, range plotting, mapping of bearings from the radar was added to it. The device was placed in the shape of a letter U, which made it easier to fit in the control room, as well as easier to supervise the operation of the whole unit by the gunnery officer. Both the action of the HMS Prince of Wales against Bismarck and the later action of HMS Duke of York against Scharnhorst give very high marks for the efficiency of the system. Was it perfect? Well, no. Interestingly, Bismarck was easier for HMS Prince of Wales to hit than it was for HMS King George V. Bismarck, with a damaged rudder, made great swivels in the ocean, and the system had difficulty with such an erratic maneuver of the German battleship. That is why HMS Prince of Wales, with a completely green crew, fresh crew, scored 3 hits on Bismarck from a considerable distance, while HMS King George, despite being in a much closer combat range, had difficulties hitting the mark. But in case of Bismarck and the King George type, the fire control system seemed to show how the school of fire control has changed since World War I. Hits at longer ranges were much more likely, finding the range was much faster, covering and bracketing practically possible from the first fired salvo. In terms of propulsion, the ships represented a significant leap forward over their predecessors, but compared to other navies, King George class was the slowest of the modern treaty battleships. The engines were good. They produced a theoretical power of 110,000 shp, which allowed the ships to accelerate to 29 knots in light condition and to over 27 knots in full combat displacement. And also for 28 knots for a short period of time in emergency power setting while in combat displacement. The engine room was well designed, the boilers were efficient, and the ships had, in theory, a rather impressive range of 15,600 nautical miles at economical speed of 10 knots. However, the sad truth is that these battleships did not reach their designed range during the war, and only after the conflict, thanks to many improvements and modifications, did they exceed 10,000 nautical miles of range. Why did this happen? First, the planned fuel supply for the ship was too modest. What exactly went wrong is not known, but somewhere in the calculation an error was made, and the ships took on board less fuel than they should have to achieve the intended result. Secondly, the increasing pace of production and work on these ships, associated with increasingly fast approaching World War II, meant that the quality of workmanship on some elements of the propulsion system left much to be desired. This was particularly visible in the matter of boiler room piping, which lost some steam pressure and therefore were of the less efficiency. Thirdly, the plant operational range was related to the use of fuel that was available in the United Kingdom at the time. High quality fuel allowed for high efficiency of the propulsion system. Unfortunately, during World War II, difficulties related to the import of fuel to the islands meant that the Royal Navy was forced to use lower quality fuel oil with higher viscosity, which was more easily contaminated with seawater. The lower quality of fuel in turn had a negative impact on the efficiency of the boiler room and caused a decrease in the performance of individual boilers. These factors caused that over time the range of the King George class dropped drastically to around 4,000-5,000 nautical miles. However, by the end of the war, thanks to the new solutions including boilers with modified spray nozzles and a tighter installations, more properly controlled, the ships managed to achieve a range exceeding 10,000 nautical miles. However, still it was less than the planned 15,000 nautical miles. The boiler room was divided into 4 sectors with 2 boilers in each sector. The boilers provided steam to the engine room located between the boiler rooms. The engine room powered 4 screws. The ship was quite agile for her size, with a turning radius of around 730 yards, 667 meters. This compared much more favorably with HMS Renown or HMS Hood, which, although of similar size, had a turning radius of 1050 yards, around 960 meters. King George was not as agile as American battleships using twin rudders, but in this respect King George was rather high up. This class of the battleship was also, which is often passed over in silence, almost completely devoid of vibration. A seemingly unimportant thing, but when you consider how much very delicate equipment there is on a battleship and how much of it's crucial for its efficient functioning, mainly for example radar and targeting system for fire control, a ship that does not dismantle itself, like the North Carolina class for example, has a great advantage. This of course makes the work of the crew easier, which in turn translates into efficiency of the entire battleship. The ships had great seaworthiness and were stable platforms for main artillery. However, the shape of the hull had a rather significant flaw, a low freeboard at the front at the bow of the ship. The King George class was still subject to the Admiralty's senseless requirement to be able to shoot directly ahead with its gun at a low or neutral elevation. This required the use of an appropriate bow shape, and this in turn meant that when encountering large waves, unfortunately a lot of water landed on the foredeck. It is true that most of it went down at the breakwater in front of turret A, but high waves could and did had a negative effect on the fire control and the amount of shots each turret could produce. That is why the last British battleship, HMS Vanguard, already has a different bow shape better adapted to keeping with high waves. The King George V type is not the largest and not the most powerful type of battleship. However, in my opinion, it is one of the best designed. Every aspect of the ship has been thought out and optimized almost to the limit of technological possibilities at the time of its creation. It is an interesting contrast to Bismarck, but also to the Nelson that preceded it and even to the HMS Hood. The armor of this ship is, in my opinion, one of the best, if not the best, that has been designed for a capital ship. Not only was it exceptionally thick for a ship of this displacement, the armor plates themselves were also of a high quality, providing the best possible protection. The anti-torpedo defense was also solidly designed and tested. The unfortunate hit received by HMS Prince of Wales does not discredit the efficiency of entire system, nor does the torpedo received by Bismarck. The ship was given a specific task and a description of how to perform it, and then a defense system was designed to enable it to perform this task. The armament was the weaker point of the ship. Although the fire control system were among the best in the world, at the time the battleships were built, the armament itself left much to be desired. The 14-inch guns were very good, no doubt about that, but there's also no denying that they were just not as powerful as 15 inches or 16 inches guns. They were sufficient to cause damage when they hit, but in case of war at sea, sometimes a single hit decided the fate of the battle. If a battleship does score a hit, it would be worth it to inflict the maximum possible damage. Therefore, if we can't have a monstrous caliber and huge guns to throw shells weighing a ton at the enemy, then we have to make sure that the guns we have are efficient, reliable, and can fire as quickly as possible to compensate for the weaker characteristic of a single shell with more numerous shells in the air. In the case of the King George V, unfortunately, this aspect was not as good, left much to be desired almost until the end of the war. Similarly, the secondary artillery also posed problems. The 5.25 inches mounts were adequate as anti-surface weapons, but they were disappointing as anti-aircraft weapons. They were heavy, they were cumbersome, which not only made them unusable when the power went out, as in the Battle of Kuantan, but also the high-angle control system controlling their fire was too slow to respond to emerging threats, and a lot of further development was required to bring it up to speed. The light anti-aircraft artillery was also inadequate. Both the pom-poms and the machine guns, not to mention the up projectile launcher, they were all just obsolete. A major advantage was the fire control system, the AFCT Mark IX, supported by radar and the director control tower. This gave the Royal Navy ships a huge advantage. They had better tactical awareness, could open fire faster from greater distance, and keep their target in sight better. The Bismarck was not far behind, if at all, in the early stages of World War II, but the lack of an efficient radar system compared to the British ships left the Kriegsmarine at a disadvantage. And with this, we will end the discussion of the King George class, and at the same time, we will close the part devoted to the analysis of the characteristics of the main actors in our history. Equipped with knowledge about the advantages and disadvantages of all the heroes of our story, we can now move on to the main part, a discussion of the course of Operation Rheinübung. I hope that the knowledge gained in previous episodes will allow us to better understand the events that will soon to be subject of the next materials or the next films. And that's all for today. I hope you liked the film. If so, leave thumbs up and let me know in the comments. And I'll be back soon with another episode of Military in Painful Details.